Density core prac. You've watched the videos for this core prac, and there were several instructions for you to find the density of regular objects, irregular objects, and a liquid. So I'm going to talk you through the calculations that you should have done. So the first object you saw was perspex, a cubic shaped perspex, and the perspex block was placed on a weighing scale and it read 9.00 grams. Then the measurements were taken for the height, width, and length, and using those three dimensions, we worked out volume by multiplying height, width, and length together. The units that were taken were in millimeters, so our volume is going to be in millimeters cubed. Often we have done our calculations in centimeters cubed for volume, so I'm going to convert this into centimeters cubed, and to do that is divide by 1,000. So whatever your value you got for millimeters cubed divided by 1,000, you'll get it into centimeters cubed. So that was 7.56 centimeters cubed for the volume of perspex. To find the density, we use the equation mass over volume. Put the values in, 9 divided by 7.56, and what we get is an answer of 1.19, and the unit is grams per centimeters cubed. Similarly, for metal A, the mass was 88.71 grams. The volume in millimeters cubed was 8,036 millimeters cubed, and dividing by 1,000, we get it into centimeters cubed. That was 8.04 centimeters cubed, and then the density is mass over volume, and that ended up being 11.03 grams per centimeters cubed. Metal B, same technique again. 21.40 grams was the mass. The volume was 7,718 millimeters cubed, which is 7.72 centimeters cubed, and mass over volume. To find the density, it was 2.77 grams per centimeters cubed. Metal C, following the same technique again, so we have a mass of 71.15 grams and the volume of 7,920 millimeters cubed, which is 7.92 centimeters cubed. Using the formula again of mass over volume to find density, we've got a density of 8.98 grams per centimeters cubed. So those were calculations to find the density of 4 regular objects. And in general, your examiner likes to ask questions. How would you find the density of a regular object? So you would put all of these points that I'm going to mention in sentences. So the mass, you place your object on a weighing scale and you take the measurement for mass. You get a ruler or you get a vernier caliper, you measure the length, the width, the height, and you multiply them together to find the volume. And then you use the formula density is equal to mass over volume to get the density. Now this is a typical exam question where they ask you, how are you going to conduct this experiment? Let's move on to irregular objects. So plasticine was shown in the video. The mass of the plasticine was 14.16 grams. The volume of plasticine was 8.4 milliliters. That is the same as 8.4 centimeters cubed. Using the density equals mass over volume formula, we get the density is equal to 1.69 grams per centimeters cubed. So How would we find the density of an irregular object? The general way to find it, as you saw in the video, to get the mass, we put the object, the plasticine, on the weighing scale and we found the mass. The volume, we couldn't use length times width times height because there was no real consistent dimensions. So we used a displacement can and we dropped the plasticine into a displacement can that was filled with water, and we collected the displaced water in a measuring cylinder and we found the volume that way. And that's what you need to say when you're explaining how you find the volume of an irregular object. And then at the end is the same formula again to find the density, which is mass over volume. And finally, to find the density of a liquid, we placed the measuring cylinder with the water and without the water on the mass balance. Without the water, it was 85.39 grams, the salt solution. And with the salt solution, it was 126.38 grams. So the salt solution weighed 40.99 grams. The volume of the salt solution that was placed in the measuring cylinder was 39 centimeters cubed, or 39 milliliters. To find the density of the salt solution, its mass over volume, that's 40.99 divided by 39, and that is 1.05 grams per centimeters cubed. Okay, that makes sense considering water is 1 gram per centimeters cubed. We've added some salt in to that water, mixed it up, so we're expecting the density of that liquid to be a little greater than of water.